So we're actually not going to build it right now. We're going to walk through a sample application that was built with ReactiveUI, several libraries in the ReactiveUI space called Social Queue. So, my usual self-marketing slide. I'm Rodney. You can find me at all these places. You can, troll me all you want. It's fun. But I'm a Xamarin developer. I found ReactiveUI actually after a talk that Michael Stonis did at Xamarin Evolve 2016. And he was telling me that I should build better mobile apps. And I was like baffled. A couple of weeks later, I asked David Driscoll, who's talking up next, about, reactive programming. And he was like, yeah, Rodney, it's great. Do it. So I broke my brain, and now I'm like sort of a functional programmer, like quasi-functional. Rich actually taught me that I'm not as functional as I should be. So I live in a capitalist society. So yeah, I know we got people on from all over the world, but I live in a capitalist society, and in my capitalist society, one of the main things that is big is free market. So, we like to capitalize on all manner of things, good and bad. And Glenn came to me and said, hey, Rodney, I've got this idea for an app. You should build it. And I was like, oh, okay, great. So we're going to kind of go through the thought process of kind of an indie developer, maybe somebody working on the nights and weekends, trying to do something by themselves, something small, something simple. Uber, when it first came out, was a 3-screen app, and it's worth lots of money now. So, it's not about the number of screens you have. It's about the quantity or the quality of the screens that you have. So we're going to kind of walk through the sales pitch for the app. We're going to look at what we're actually building. We're going to take a look at the scaffolding, and then we're going to talk about some future features that may come to this. And again, all of this code will be publicly available after this talk. So Glenn had this idea for an app, and he was like, hey, Rodney, I've got to go out this weekend and I've got to go do some stuff, but there's all of these unmanageable lines. I myself had just come from going grocery shopping with my wife, where we had to stand in line and wait for folks to come in and out. And it dawned on Glenn that, hey, what if you had the ability to queue up for these outings, right? What if you had the ability to say, hey, I need to go to Home Depot and let's call it Target and Best Buy in a given day, but they have capacity limits, and I want to be able to schedule out my day so I don't have to wait in line physically, because I live in Texas where it's really hot, and standing in line in the middle of the summer is not really what you want to do unless you want heat stroke. So if I could have a virtual queuing system that says, hey, I'm going to queue up for a given store and find what their weight limit is, and adhere myself to that information, and then get real-time updates from that information on if the queues have changed or if other things have changed. So we can use RX, right? SignalR can push updates to a mobile application. We can use Azure Functions to store data in Cosmos DB. We can use Cosmos DB to update. Cosmos DB has like an eventing concept where it can actually push events through SignalR and SignalR services and project data from the database, or changes from the database, out to broadcast consumers. We elected to use Shiny for the platform services because Shiny is a nice new thing, and I like shiny new things. But it'll allow us to get stuff like location services, so we can determine the distance between certain establishments to determine whether or not we might want to put certain things in priority above other things. We are going to elect to model our asynchrony as observables, and I'm going to continue to harp on that throughout this conversation. As a matter of fact, when we get to the code, I'm actually going to pull up and I'm going to show you the number of places in the code where I actually do async task, because and Anna said it earlier. One of the things is observables don't necessarily replace tasks, but they are an alternative way to model asynchronous programming. And one of the main things that I find about asynchronous programming is people consider when I do await, and fire off a task, that I'm actually running on a new thread context. Well, that awaited task is not guaranteed a new thread context. It could potentially get a new thread context. But with observables, we can explicitly send you to whatever thread context we want at pretty much any point in our observable pipeline, and change that at different points of execution in our observable pipeline. So we're going to model events as observables, and then we're going to use ReactiveUI, specifically ReactiveUI for handling mutable state. So we can target multiple platforms. One of the things about multi-platform application toolkits is the fact that I can reach more users if I can target more operating systems. So for this, we're looking at targeting iOS and Android and using Avalonia UI to target desktop. But the primary focus of this is going to be the Xamarin aspect of it, as I still have yet to dig fully into Avalonia and figure out exactly how to make it work the way I want to with my Xamarin Forms application. So what is Social Queue? Yeah, it's the new hot app. Yeah, it's going to allow you to go ahead and plan out your entire Saturday afternoon, get updates from various establishments when their capacities are available. It'll tell me when things are different, when I'm getting close to closing times, and all sorts of other wonderful things, right? It will allow me to take back control of my life in these crazy times. Yeah, so that was kind of the whole thought process behind it. So what do we need? As we said before, we're going to use Azure Functions and SignalR in Cosmos DB. On the front end of it, we're going to use Xamarin, like I said, in Shiny. We're also going to use Refit, ReactiveUI, Sextant, which is a navigation library, Pharmacist, which is going to generate a whole bunch of observables, Dynamic Data, which now that I know how it works, I don't know how I lived without it. I guess that's RX in general. We're going to use RG plugin pop-ups as well, and Acrobat to do our caching behind the scenes. So what this app needs to do essentially is display a list of stores. We need to allow you to filter that list of stores by searching free text or by category. We need to allow you to queue up for a given establishment, give you some potential countdown timer on the time left that you have on your wait, and give you some notification when that time is close. So let's go ahead and jump directly into the code, yeah, because that's enough talking and we've looked at enough slides, and now it's time to dig into some code. All right, so, oh, is this thing on? Am I still not?
You're fine, you're coming through.
Okay, good. All right, so let's just go ahead and jump in and just talk about the realities of this application, right? So it's a Xamarin application, but before we get too far deep into those weeds, yeah, Rodney's clicking buttons again, doing his normal button clicking thing. Let's kind of walk through some of the bits. I actually brought Sextant in as a Git submodule so that I can create a feature that's going to probably ship in the next week or so, which is RG plugin pop-up support. But more importantly, we've got some Azure functions in here where we're going to do some queue storing and some other things. And I think we're going to kind of start our journey there. We've got some different things that are happening in our source folder. Like I said, we've got several targets. We've got our Android target, our Avalonia target, and our iOS target. And then we've got some unit tests in here because no good project is going to be successful without at least a place to run a unit test, even if you just delete them all afterwards. But you'll notice here that I explicitly have a social queue.xamarin forms, and this is where all of my Xamarin UI layer stuff is happening. And I'm keeping all of my shared stuff kind of behind the scenes here in this project where I've got my social queue. So this could be like a .core project or a .common project. There's a lot of different ways that you could do this. But lo and behold, this is the way that I elected to do it until I find a need to shift. So I've got some, here we go. So I've got some I've got an Azure function that is just stuck to a Cosmos DB. It's going to allow me to update a queue selection. So when you'll notice here that I'm actually using SignalR as a service and not the actual full-on SignalR backend. So I didn't stand up a web API and go through all the rigmarole there. I just turned on the SignalR service on my Azure function and allowed me to get access to the SignalR backplane, and I can push messages on that SignalR backplane. The reason why this is important, SignalR actually plays really well with the concept of RX because RX is all push-based collections and push-based notifications. And that's basically what SignalR does, is it's pushing you events or messages or notifications from some backend that is doing work. So it really fits into the reactive model where we just want notifications or state changes that we can respond to. So the way this all works is Cosmos DB will actually emit a trigger under the hood, and then it will go off and create the update and push the update down on this SignalR message. You'll notice here that it's not wired up because the functions actually got kind of a little bit unwieldy, so I had to disconnect them because they were causing some Azure problems. But all of this is more or less functional. And more importantly, kind of the next bit that I want to go into is I'm actually able to mock out my backend services. So I'm not actually bound to these Azure functions because Azure functions is a pay-as-you-play concept. So if I've got a API where I'm paying to play and I've got a team of developers hitting it, then that's probably not the best idea. Also, on that thought where I just don't want to pay for things that I don't need. So if I don't need to go and incur the cost against Azure or against AWS or against whatever my cloud backend provider is, there's a trick I'm going to show here shortly, which will allow you to write a mock layer into your Xamarin application. So instead of having to deal with design, time data, and some of that stuff, you can actually build out, and I'm going to show you that trick in a minute, you can actually build out an entire disconnected application state where you're dealing with mock data with very minimal change in your application. And instead of having to mock out like 3 and 5 and 10 layers, you really only have one layer that you have to mock. You only have one layer that you actually have to mock, and then everything else in your application just works. So you're getting more of an actual real world test of your application. You're just mocking out the data. So I've got a lot of, I've had the good fortune of being a mentee of a lot of smart people. And one of my mentors once told me, he said, Rodney, do you want to mock the data or do you want to mock the data source? And I realized in that moment that I was making a very critical error in my approach. So that's kind of the SignalR aspect of it. I'm not going to dig too much into this because it's really more about the Xamarin piece, but that is with this application and will be all functional and available for anybody that wants to pull it down and look at it. So kind of digging into it, again, I said I use Shiny as a way to do platform services. So this is a way to do startup in Shiny. I'm using Shiny, which actually uses the ASP.NET Core iCollection service concept. It's not ASP.NET Core, it's just Microsoft dependency injection. But it's widely used in the ASP.NET Core space. So just the ability to wire up services. So you'll notice here that I am not explicitly using Splat as my container of choice or service locator, but I am still using Splat. I'm using a feature that we built into Splat a couple of releases ago where we actually started to ship adapters for Splat. So what's going to happen in this method here is I'm going to wire up all of my services to the Shiny host. So Shiny has access to whatever it needs, which in this case is actually probably overkill, and I could probably rewrite this to be a little bit cleaner. But Shiny is going to get all of the services and register them against the Microsoft dependency inversion container. And then I'm actually going to use this Microsoft dependency inversion resolver. Let's go ahead and F12 into that code real quick. And you'll see that I'm going to take that and create a new Microsoft dependency resolver and set it to the locator. What this does is under the hood, it makes it so that the everything that resolves through the locator, i.e. ReactiveUI uses the locator to resolve various things that it needs. Those things will actually now go through the dependency, the Microsoft dependency resolver. So you'll actually be resolving those things from the iService provider actually, but from the iService provider as opposed to the locator itself. So that's a neat trick to where if you want to bring your own dependency resolver, if you don't like the way location services are done, if you've believed the dogma that service location is an anti-pattern, then this is a tool that's available to you. I've had some things recently where I've realized that service location isn't the anti-pattern because service location is a tool. It can't be an anti-pattern, but tools allow developers to do bad things, and that's where anti-patterns come in. When you use the tool incorrectly, you create the anti-pattern. So anyone who's ever spouted the dogma of, service location being the anti-pattern, I'd say, did you do it right? Anyway, so here I'm registering my pages for navigation. I wrote some custom navigation stuff for Sextant to just say, hey, this is a page, this is a view model, wire it up. Sextant is our navigation service of choice here, and it is using RX paradigms to provide view model first navigation in the Xamarin Forms space. Currently, we support Xamarin Forms and UWP. I have been sitting on a Blazor implementation for more months than I care to count, and I know WPF is on my radar going forward. So trying to make this the kind of natural evolution. You heard Andres earlier say that the navigation story in RxUI isn't the best. It's because of kind of the net evolved and the platforms that it originally supported versus the platforms it supports now. But so I'm just doing all of my dependency registration. Now I've got an actual dependency or a resolver that will give me view model injection, and I can kind of go off about my business. So this kind of gives you an understanding of how all that's wired up. But we'll talk about this here because I told you I'm going to show you a trick for a mock. So we'll kind of get into what that looks like now. As I said, I'm using Refit as my API connection. So I'm using Refit to actually call my Azure function layer. So you'll see here I've got a social queue, AzureNet, Azure website. Everything's great. I'm doing a generic setup for my iHub client, so that way any hub client that I have, I can just use the generic type off of the SignalR client and get some code reuse there. But you'll notice here, I'm actually mocking those same contracts. So I've actually got mock contracts that will wire up to my actual contracts, and all they do is implement the same contract as the Refit contract. Yeah. So the Refit contract is here, and on my stores, I can get a store, and I can get some metadata about stores, right? So what this will allow me to do is mock out, and I actually am using Bogus here to do some data generation, but I can mock out my data on my mobile application. And now when I actually spin up the application, I can have click-through screens that simulate what the app's going to look like. Now this is good and bad, right? Because you can have the scenario where you're doing some testing against it and the testing works, and then you spin it up to your back end, and out of nowhere everything starts failing. Well, yes, that's a problem, but at the same time you may have already had that problem, and really all you have to do is check the seams at that point. So it makes it a little bit easier for us to start identifying where that might come up. I'm actually going to run this entire demo in disconnected mode, so you're actually going to see all of these things happen. I'm not ever actually going to hit this Azure instance.
We just had a question from a user on YouTube. They're just asking if you're going to share the source code.
Share the source?
Yeah.
I mean, for the entire build app, yeah, I'm going to share the source after the talk. So it's actually technically already publicly available, and if your Google Foo is good, you can find it. But I'm going to provide the exact link to it after I get done talking about all of the details. And that was kind of the point of this, was to leave an artifact, right? Because when I came to ReactiveUI, there was very little, samples, and we create a lot of samples, but contrived examples are contrived examples. So, we tried to build some level of real world. This is still, at best, this is a prototype. It doesn't really get you 100% of the way there, but I feel like this will get you closer than a lot of the, hello world samples that you would see. So yeah, we'll make sure that that's available to everybody after the talk, and it'll be available on the YouTube link afterwards as well. So this whole thing is going to be done disconnected. So I'm going to show you how all that works, but then I've got some other things, and I think we'll kind of dig into the whole, to the Refit contract piece of it here. So like I said, I've got my Refit contract, and I explicitly am using terminology called contract because when I came from a web world long time ago where I was doing service-oriented architecture, and we would always define contracts for how we were going to communicate across boundaries. So in my mind, this is a contract for how we're going to communicate across the HTTP boundary. And again, I'm going to point out that refit actually does out of the box uh, return iObservable and respects iObservable. So again, I told you that I'm using iObservable to model asynchronous programming, and this goes all the way down to my HTTP layer. Even the layer, the closest to the metal in the system here, is actually using iObservable to do asynchronous programming. And I said I would do it, so I'll just go ahead and do it now, right? We'll go ahead and look for async task, and you'll notice that the only places where you find async task are primarily going to be in this function. You find one here, which is the authentication that I didn't wire up. Shh, don't tell anybody. It's completely unsecured. Don't tell anyone. I didn't wire up the actual access. That's another thing that I'm going to do, and I'm going to keep iterating over this over the next couple of months and try and make this better. So feel free to leave issues about stuff, features that we want to add, and we can kind of make this a artifact that the entire community can use to understand how these things can and or should work. But again, you'll notice that I'm actually not using any asynchronous tasks in my forms layer, in my shared code. So everything here is truly being modeled asynchronously using iObservable. And this is why I said I'm going to actually talk about subscribe on and observe on, because around 3 o'clock in the morning, I hit a snag where observe on didn't work the way I expected it to work. And I was like, wait, maybe I'm supposed to subscribe on. And I was like, oh, I'm supposed to know these things. Anyway, so the way this works is my contract gets pushed into a client, right? So and this is like all the way down the chain. So my client is gonna get stores again, and this may seem like some level of onion architecture, but it's not, and we'll explain it and we'll get there. And there's a couple of layers, but the layers have reasons and meaning, and all of it will hopefully make sense as we finish. So my API client is actually going to take in, so I've got one inheritor of that API client, and I told you earlier, the rest of my application is going to work fine, right? Because I'm mocking out the actual data source. The HTTP contract that is getting the data is I can write a mock that will just give me data. So now that's going to get injected into my API client, and you'll notice what else gets injected into my API client. I'm taking a blob cache, which is my ActiveAsh layer, and I'm taking in an iLog manager. So now I have access in my client layer to cache the things against my database implementation, for lack of a better term. Underneath the hood, ActiveAsh does have a database and it does have access to like a SQLite database if you wanted to use it. I don't know if I'm using one here, but that is an option available to you. There's also in memory as well as JSON, I believe. So I can take the bits that come from my result and immediately cache it into my database or my data store. And how that looks here is you'll notice I've got this get store, and I'm calling my API contract. And when I go to get my API contract, I'm doing get store. The get store is actually going to return the iStore DTO, right? So I'm returning the actual store that comes from the HTTP request. And because it's an observable pipeline, and again, this is where I think tasks are lacking, because they don't really allow for me to chain a pipeline onto it, which is funny because if you look at, we'll go back to the .NET Core framework. If you go back to like the HTTP handler stuff that beforehand, and even the HTTP handler stuff in .NET Core now is actually very similar to an observable pipeline. We're just taking some value, pumping it into some function, and then whenever that value mutates, I'm taking the mutated value, if it does mutate, and I'm passing it to the next function on the chain. So what I'm doing is I'm going out to the web, getting my HTTP contract information, stashing the cached result. So what I'm doing is I'm actually going to ActiveAsh and saying, hey, I've got this store by this ID. Go ahead and cache that in ActiveAsh and allow me to log. Task T is a monad, and you can change the thing all day. Yeah, task T is a monad, but what task T doesn't give me is a consistent API to work with asynchronous programming and events in the same chain. So while I can do it, it's not as clean or intuitive to a user how they would actually do it. And I think that's the
Oh, come
main.
on. You said to troll you, so I'm trolling you. Come on.
Please. Oh no, no, I love it, Rich. I love being trolled. Call me on it because I may not be right. So yes, Rich is correct. Task T is a monad, and you can chain it. You can use continue with. I've been actually using that recently, much to my own dismay, but it works, and it is a tool available to you. But it's a little bit more difficult, and I don't have the ability to do things on certain thread contexts as well. So while Rich is right, you can do it. I'd rather not because it's a little bit more cumbersome than I care to deal with. But you'll see here that now every time I call, I'm actually calling into my cache layer. So like, what does this method look like? This method has a expiration that we take in. So we've got some constants where we're setting our cache timeout. And then if you provide the override, we go ahead and give you that value that you override. Rodney did not do some stuff. So you'll notice a couple of weeks ago, oh, that's actually a while ago, I reminded myself that I need to add some retry logic. I have the ability to, but I have not done that yet. And I can go through some of that as well. But you'll see here that what I'm doing is if I need to force the update, I'm actually going to go out and get the information inserted into the cache. If not, I'm just going to go to the cache and get it. So now I'm allowing my public consumer to tell me whether or not it wants to go against the cache representation of the data or go get the data directly. And because we're using Akavash is one of the few caching libraries that has this feature. And it's because you really actually need observables in order to do it well. Which is this get or fetch. So what it'll eventually do is it'll actually go out and fetch this call anyway and store it. But what it will first do is return me the value that it currently has in the cache. So this actually can bite you. And it was trying to fetch it, and it was blowing up all types of ridiculous fun stuff. So these things are not silver bullets. There is no panacea, there is no silver bullet, but these are things that could get you further along down the way, right? And it kind of shows you the fact that we are using functional programming in a manner by which to chain together operations over streams of values over time. So that's one of those places where you might want to use that select concat that Mike was talking about earlier, right? Because we're getting these values over time, and then we can operate on those values over time in ways that other things don't really provide a succinct API to do. So this gets passed back up the chain. So my iStore API client is actually going to be called from my iStore service. And this is where the real fun begins, right? Because you can see here that I expose on this service this Observable Cache. This is a trick that I learned from talking to other RX programmers in the industry. When I first found out what dynamic data was, I had no idea what it was. I was like, okay, I don't get it. And then when I found out what it does, I was like, oh my God, it's great. I'm going to cache all the things. But you'll notice that I'm explicitly using a source cache because I have a unique value. So anytime that you have a set of data that has a unique identifier, I personally would urge you towards an observable cache, primarily because it's got a key, and anytime you have key value data, you're gonna move faster than if you don't. I mean, if you have to traverse the list, every operator is available to you, like add or update, which you saw earlier. Or maybe you didn't. I can get to that in a minute. Add or update that comes off that Observable Cache. But you'll notice that my data store as it is, or my store that is actually going to be, and this is the thing that's actually going to get injected into my view model, and we'll show you that in a minute. This thing that gets actually injected into my view model provides me a source cache. So now my view model layer has no understanding of how it connects to data. It has no understanding of how to cache data. All it knows is it has data and it can operate on that data. And I'm going to go out on a limb here and say, having worked around MVVM for the past several years, the number one thing that I see people do wrong is they provide knowledge of the view to the view model. The number two thing that I see people do wrong is the view model becomes this place where you glue a lot of code together. They do HTTP requests and database saves and try catches around database stuff to make sure that it all works. And it's not that you can't do that, but I don't feel like that's the view model's concern. I gave a talk, oh God, at this point, literally 2 days ago, where I kind of broke down the way we approach reactive and the mental model around reactive programming is really much more around dealing with events and streams of values and less about, or it's really about, you know, managing that mutable state or dealing with that mutable state and dealing with state mutations. It's not really about, hey, I've got this view model and this view model is the global place where I can put my global stuff here, right? Let's find techniques where we can actually create better scenes so that the layers only have to interact with the things they need to interact with. Here I'm actually providing an iObservable of iChange set of metadata, which is just string values, which is actually just the store names right now. This is actually a observable that I have connected to and I'm getting data from versus the iObservable cache. So I'm actually going to take this iObservable cache and turn it into this metadata, and I'll show you that in a minute. I get my stores, I get an IEnumerable stores when I get all my stores, and I get my IEnumerable store metadata. And this is the thing that gets passed in my actual view model. So looking at the details of how this is set up, you'll notice again, I've got my injected IAPI client. I can do more in this layer, but I don't necessarily need to for this application. But it gives you a clear separation to do that. So here I'm passing down my concern of forcing the update. I've got this extension method here where I can pass in a cache and add or update. So now instead of actually just like having to create some really awkward thing where I do some stuff, I'm just gonna go ahead and add or update in some extension method and move to more of a functional model. I'm actually gonna thank Rich for this because Rich is the one that made me realize that I was doing it wrong. And I'm probably still doing it wrong, but I'm doing it better today than I was yesterday. So that's progress and I'll take it. So we're gonna just go ahead and add updates. Here we're gonna add ranges. And here we're going to just add or update the individual store. So now you'll see that as my data get pumped back from my API contract and gets cached in my blob cache, it's then gonna pass back down to the other layer and it's gonna say, hey, now that I know that I've made a valid network request and I know that I've saved myself in the database, let me save myself to the in-memory representation of my data. And then I'm gonna go ahead and then further pass that back down the chain. And again, as you see, this is just passing on the same iObservable information that you already had. It's nothing really magical at this point, and you get your data back down. So let's go ahead and dig into the view model now, because this is where the fun begins, I think, maybe, I don't know. Here is my sextant bit, and I think we're going to go talk about the main or the view model base here in a second, which is my extension point. But again, so that I'm not a liar, these are now all the dependencies that my view model has to resolve, right? The only thing it's really resolving are things that allow it to interact with the view and things that allow it to interact with data. It has no knowledge of where the data is stored because it really shouldn't. All its responsibility is dealing with mutable state, right? State that is in memory, state that is in flux. It doesn't have to worry about where the downstream concern of how the data is getting from the API. We don't care. All we know in our view model is we have mutable state, and we are going to be able to act on that mutable state in some fashion. So now our view model is very light, right? We don't have a whole lot of concerns we need to pass in. We're dealing with very, very lightweight things that we are passing in. We're dealing with a way to navigate and a way to display notifications. Really nothing more, nothing less. And I'll use this moment to kind of dig over here. You'll notice, and anyone who's used Prism or has seen Prism before will be familiar with these looking things. I will go ahead and be honest, because this is open source software. I went out when we first started down the road of Sextant, which was some years ago now. We looked at all of the MVVM frameworks and how they do navigation. We looked at ReactiveUI, we looked at Prism, we looked at MVVM Cross, we looked at Fresh MVVM, and we looked for some consistent themes and some things that we knew we were going to be concerned with. Specifically in RX, we care about disposing of our dependencies. So this iDestructible was something that we wanted to get in because this gives us an extension point for us to dispose of our view model subscriptions. I will point out that I am not electing to use when activated and the deactivated pieces here. A couple of years ago, actually asked Anna about this, and she said that I'm effectively achieving the same thing, but it's unfortunate because now you have to do something different for different platforms. The reason why I started going down this approach and creating my own composite disposables is because there is a bug in Xamarin Forms that is dealing with iOS view appearing and disappearing. So I ran into some issues with the view activation, and ever since then, you know, I'm very much the type of developer where once I've been burned by a piece of technology, I try and stray away from it if there's an alternative that works better for my mental model. So here, the base view model actually has a subscription, and I'll point out the fact that I'm using explicit interface implementation actually allows me to alleviate the need for the developer to actually ever call this. Like the developer, another person on my team that's calling this view model base, never actually has to call this destroy method. It never has to do like base.destroy because the interface is just going to call the virtual method. So if you want to do more than just dispose of the general descriptions that are going to be on your view model, right? You can do that by overriding the destroy and just giving it whatever values you want, and it'll be good to go. So that's a very keen trick that I've been using recently, and you'll notice that it's there for all of my when navigated to, when navigated from. So in Sextant, we actually have the ability to pass navigation parameters, very similar to the way Prism does it. And that iNavigation parameter is just a dictionary of parameters that you would want to use. Or that you would want to get out, and we'll show some of that in a minute because I'm actually using some of that. And part of the feature that I wired up was the ability to do this using RG plugin pop-ups. So I'm actually using some level of this to navigate through my details and all that stuff. So I think that's the basis of that view model base. So we can kind of kill that and go back here. So I think probably everybody's seen the default RX search example. I mean, it's out there on the website. I've done it ad nauseum. I've showed the code ad nauseum. But I realized that we may not always want to fire off against the internet, or we may not always want to search some random thing. We actually want to search the eventuality of, okay. We actually want to search the list. So here I've actually got the filter stuff that Michael was talking about earlier. I'm actually spinning up a behavior subject, and I'm allowing this to be my search function, or really this should actually be filter function because naming things is hard. But this is actually going to be what filters in the entirety of my dynamic data cache, right? So again, I'm doing my connect, my ref count. I'm filtering, I'm transforming out into my view model. I'm observing on my main thread, primarily because this function could technically happen on the task pool scheduler, and I know I'm going to want to update on the main thread. I'm going to bind out to my my read-only observable collection, and then I'm going to dispose. And you'll notice here I also have another, the same thing that I was telling you earlier. This is my actual observable change test, so this is live data that I'm getting. I'm going to show you some of this in a bit, but this is loading and when in the observable. But this is a keen trick to setting a is loading property on across multiple things, and this kind of really shows the power of a when any observable or when any value. Because you can chain together a lot of different properties and then merge those things together. Or really, it's actually not a merge; it's a combined latest. But you can get all that stuff together and make it function. So I think I've done enough kind of perusing through the code and just talking at this point. Now I kind of want to just spin it up and talk through a little bit more and talk through the various aspects of things. One other thing that I will point out that I did in this app, and again, all of this is publicly available. I'm available at all of the mediums of communication that I posted earlier. So if anybody looks at this code at some point in the future and wants to ask more questions, open an issue, reach out to me on Slack, Twitter. I'm all about trying to help people understand what I couldn't figure out easily. So yeah, I think one of the things that I want to point out is I actually created this concept of some startup tasks, and now Shiny has a concept of startup operations, but I've used sync frameworks in the past where I've actually had to go and create some form of operation that has to happen while you have your splash page. So I've got this splash view model where in my splash view model, what I'm doing is I'm taking my Iap Startup. My Iap Startup is just a startup function, but what it does is it actually is going to go through my list of startups. So I'm actually registering these in my IOC container, and I'm saying, give me the list of startup operations that need to happen, and run through that list of startup operations, and then observe and complete. This is actually something that I realized a couple of weeks ago. I was having some conversation with one of my mentors, and I realized that I have been doing this wrong for a very long time. There's a concept in part of the reason why task is easier to deal with from an asynchronous perspective than observables is because a task really is a single value observable. It ticks a value and then ticks its completion, more or less, right? So here's my value and I'm done. So anytime you're modeling observables as asynchronous programming, you have to be aware of values over time. And if you do not explicitly complete the observable, that thing will run forever and you may end up in like an infinite loop. I've done that more times than I care to count. And I literally just realized this week that stuff like this is really, really valuable. So, I've been doing functional programming for about 2.5 years now, maybe 3 years, and I'm still learning, beginner stuff, as it were. So this thing right here is actually a notification access operation. So I'm using Shiny's iNotification Manager, and I'm requesting access for notifications. And all of that is actually happening on my splash page as I load up. Notice it's not still spinning on my splash view model. Rodney's a great programmer, and he messed up the very simple thing of making sure that it blocks completion until all of the startup operations are done. But that should be a minor fix. Glenn earlier pointed out the toObservable. The toObservable extension method, more or less, is really just wrapping that thing in a observable from async. In this project, I elected to go with the more verbose route so that people could see how to interact with this operator and to kind of start to understand how some of these functions work. But if you're not familiar with RxJS and you go look at RxJS actually uses more of this syntax rather than the Fluent syntax. So you actually have to pass in all of your functions as opposed to using them as extension methods. But I'm going to go ahead and I'm actually going to turn this off, go in here, put this breakpoint here to kind of show something. Is that even the right operation? That may not be the right startup use operation. Yeah, I think I want to talk about iSettings. I got a breakpoint on the notification access. So these things basically are just kind of like a poor man's chain of responsibilities. We're just going to give them a thing to whether or not they can start. Why that's important is because on my splash view model, again, we're working in a disconnected state. I might want to, while I'm in debug or while I am using mock data. Come on, Ryder, you can do it. It's not going to do it. So okay, whatever. We're just going to keep going down the road. Nothing to see here, folks. Pay no attention to the man behind the curtain. Yeah, you notice that's my loading indicator, and we'll kind of get back to that. And these can starts, right? So I can turn the delay operator. I can always register the delay operator and just say, hey, when you're not in debug or when you're not using mock data, just don't use it. Just don't use the value. But enough of the semantics or the meat and potatoes of this is, when I put a breakpoint, if Ryder is going to let me put breakpoints while I'm debugging, it may not. So let's go. I don't think I'm on the latest Ryder. So another fun fact: don't schedule demos during WWDC or when iOS is doing major version updates because you will break. iOS Xcode actually updated on me yesterday afternoon, all without me knowing. And I spent a good 2 hours recovering my system so that I could finish giving this demo on iOS because I had spent the majority of the time working on the iOS head. But what I'm doing with this search function is I'm allowing down here in my writer, just keep being fun. So yeah, Ryder is actually going to go ahead and tell me when all these things are happening. So now you'll see over here, Ryder is actually telling me which observable is ticking and which one actually has a truth value. So Ryder is actually allowing me to set a breakpoint in the portion of the when any observable where I'm actually doing my selector. It's letting me put a breakpoint there and evaluate those values, which is extremely useful, as we'll see here in a second. Because right there it was just the initialize, so now I've initialized, but I can go ahead and trim down by category. So you remember earlier on the slide deck, one of the features that we wanted from this thing was to be able to search in the text bar or sort by category. So you'll notice there's no data here. I had planned to do some type ahead stuff, but time permitting, it didn't happen, but it'll be a feature that comes later. Notice here now the category has ticked true. So on my reactive command, the is executing properties of all of my reactive commands are setting up this is loading indication, and then I'm just propertying it out. Again, I'm using the name robot because I like performance, and I'm deferring that subscription, which is a very important thing for this particular thing, because otherwise you'll subscribe and these things won't actually be constructed based upon the way I have it, and it'll cause you some headache. But now you see I've got a list, or maybe I don't. Yeah, I've got a scrollable list of restaurants, right? So I can go to Thai Lao Market, which is like one of my favorite Thai restaurants in Houston. I can go to McDonald's, Fuddruckers, hopefully a Velvet Taco is another one. Torchy's a great one. If you ever come to Houston, Torchy's Tacos, Velvet Taco, great. They're like gourmet taco places. If I can find one, Glenn, what's one of the things that's in Australia? Because I'm pretty sure I wired up some Australia stuff here for you. I want to say like, was it JB? Maybe, yeah. Let me click search, and search is executing. So maybe JB, yeah, JB Hi-Fi. So yeah, JB Hi-Fi is one that's in Australia. So I can now you can see I'm searching from that same data in that same list, which is actually the data that's in the service that I have projected into my view model, and I'm able to do a filter on the restaurant type, and you can see that the category is happening. I can now go off and do all of that. I can check by sporting goods stores. The only ones that seem to be here right now are Academy, which is one that's local to Houston. I'm sure I don't have any laundry mats available or any laundry available. Yeah. And maybe some furniture stores, right? So, as we're sitting here Friday night having dinner, my wife and I can say, hey, she wants to go to Rooms to Go tomorrow. So we'll go ahead and click on Rooms to Go. We'll get the RG plugin pop up. So this is where the sextant library was very important. Over here in my store details view model, I've got the ability to override that when navigating to. You'll notice that I'm creating an observable and I am getting the value out of the dictionary. I'm setting the store ID and then I'm returning disposable. Now, this is where reactive programming really starts to become good and bad. And I know I'm running up close to time. Reactive programming can be good and bad in that I've also set a when any value on the store ID, and I'm excluding the empty case, doing a distinct until change, and then doing my get store. So what I'm doing is I'm actually passing the value of the item that I clicked on, and we'll go back to here and show that. Here I'm using Pharmacist to generate my events. So you see I have the item tapped event on my list view, and I'm explicitly using a Xamarin Forms list view for a couple of reasons, because of the item appearing event information that comes off of it. But I'm doing my item tapped on my list view. I'm selecting the item. I am casting it as the binding context, and I'm going to invoke the command and pass the entire binding context to my command definition. So you'll see that here, right? So what then that details goes and does is, here we go. It's just doing, the pop-up view stack service. and it's saying go ahead and push the pop-up. It's passing the navigation parameter over, and I think we're going to actually put a breakpoint here so we can look at that. We have to put it here. We can't put it there. And then I'm getting that back off on my detail view model and hydrating my pop-up page. This is kind of like a really big thing because when I came to Xamarin Forms, I didn't understand how to pass data between screens. I've seen a lot of different ways to do it. The recommended way from Xamarin Forms was less than ideal. It was to use the binding context and do a lot of binding context switchery. But every time the binding context change, it notifies property change. So that's stuff you may not want. You may not want when you're doing it. So here, you know, like I said, I can now add this to my thing, and I get my nice little notification that says Rooms to Go has been added to my queue. I come over here and you see Rooms to Go is added to my queue. It's got an hour-and-a-half wait time. I haven't filled out all of the details on the card. Again, you know, at the end of the day, we can add map services and some other things and some location services, which is all part of the plan of this app. But those are the future features that we're talking about. And we can now go back here to our search page, and let's say, wow, you know, after we go to Rooms to Go, we know we're going to be hungry. So let's take that breakpoint off because we beat that horse to death. So now let's say, you know, we want to go to Fuddruckers because we want a burger, right? So Fuddruckers has a closing time of 12, opening time of 12. But you'll notice here now I've broken on this execute details. I've got this ID, which is my GUID value for my store. So then when I go ahead and F5, I'm actually going to now on my store detail view model after the before the navigation is happening, while it's navigating, right? So it hasn't actually done the navigation yet. This is happening before the view is actually put onto the stack, onto the visual stack on Xamarin Forms. It's going to go ahead and get that out of the parameter, which is, again, just a dictionary. It's going to set that store value, and it's going to fire off the command. And now you see I get my pop-up page. So I can go ahead and add Fuddruckers to the deal. And, you know, my wife likes those types of stuff, but I think I potentially might want to, you know, go to Home Depot or Lowe's or Bunnings because, you know, I want to go ahead and do some home projects for the weekend. Maybe I need to go ahead and put a studio on the outside of my house like Brian Lagunas did, which I'm extremely envious of. I love to have a production studio off of my house. But you see, now I can go ahead and do that. And again, this is using dummy data at the moment. Hey, but you can see that now I'm adding all of these things to my queue. These time values are happening. I originally was going to write a chaos monkey that was just going to come in here and swap these values out. But, you know, as things are happening, we've written a Signal R queue hub. We can find it. Client. So we got a hub mock client, right? So this is actually not the one we want. We want the other implementation. Yeah, our Signal R1. So our Signal R1 is just going to connect to the Signal R stream channel. It's going to try and read out the value. And it's just going to on next on the observer. So on the observer of whoever is observing this connect is just going to get values. So Signal R could push us an update and say this has changed, and maybe I can go and show you that real quick. Client mock. Yeah, so let's go. I had some chaos monkey stuff that was happening in here. I don't know if it'll actually work right now. What it should do is every 8 seconds, it should just go grab one of the things and change it. So it's not working right now, but
This always ends a question from the users. Are you planning to do more stream work for this on your live stream?
Rodney, I think you've lost sound again.
Yeah, I think sound's lost again, Rodney. Don't think he knows it. Oh no, he does. Every time we think he doesn't. Can you speak, Rodney?
Is there anybody there?
He's aware of it.
Quick, get your insults in now.
He's a balmy lad. I don't know.
Okay, so it seems like my mic is just randomly disconnecting or losing power. That's really disheartening. Oh, anyway, apologies, folks. You know, I guess I didn't sacrifice the right size goat to the demo gods this morning. So here we go. So we're doing all of this based upon a remaining time, right? So we actually I just wrote a timer that gives me the remaining time off of a time span. And what that looks like in, where are we using this, the usages of this? We're doing this on the actual item view model. So on the item view model, each queue item has a remaining time that gets pushed to it from the server. So basically every time that gets updated, this value will just update. And I want to say, if I go look at the queues view model, that I'm specifically sorting descending by the current queue time. So what's going to happen is when that time updates, the one that is truly the lowest will bubble up to the top. So this queue page will always show you the one at the top that is actually going to be closest to your actual timer. So, you know, when Home Depot has capacity for me and says, hey, Rodney, we can bump you up 30 minutes, it'll actually bump me up 30 minutes and it'll bump up on my actual queue. And it's doing all that using dynamic data, some sorting, some auto refresh on an observable property, and this very simple implementation of a timer. So I know I'm running up on time. I'm going to kind of pause here and ask, are there any questions? And I think I covered pretty much everything I wanted to.
There's one question on YouTube. They want to know if you can pick up a sausage for him from Bunnings.
Yeah, I can pick up sausage. I don't know if you want the beef or the pork beef mix, but just let me know which type you want, and I'll pick it up, honey, and I'll bring it home.
It's always beef in Australia for sausages, and Bunnings generally do fundraiser with sausages at the front. So,
but yeah, this is so this is just like a way to approach some functional architecture, which gives you kind of a little bit of flexibility, right? It has some functional built into it. It's still using dependency inversion, you know, that all of the solid people would clamor about if you weren't doing. You know, location being an anti-pattern and all, but we're using functions to segregate our layers, get value out of the stream of value concept or promise that is observables. In a couple of places, we're actually merging observables, asynchronous tasks with events. Oh, that's what I wanted to talk about. It's going to be in the material dialogue. So this is this is where I screwed up the other day. And going back to observe on and subscribe on. So I'm going to kind of piggyback on what Glenn was talking about. Earlier, you've heard a lot of people say, hey, when you have this method and it takes in a scheduler, you should probably give it a scheduler. Well, what I read was that it converts it into an asynchronous action into an observable sequence, and each subscription to the resulting sequence causes the action, right? But what we don't realize, and I actually had to F12 into reactive extensions to get this fidelity, it tells us right here in the notes on the param that this is the scheduler on which to notify observers. So this is the real crux of observe on versus subscribe on. Yes, everything is a notification, right? Observers get notified when something happens, right? Something changed, something changed, something changed, right? That's a notification. And we're saying that we're notifying on the scheduler. So if I pass this thing that is happening on the main thread, and this is actually how I was getting that nice, let me mute all my breakpoints real quick. That's how I was getting this nice thing after I added it, right? That's that all that is this little snack bar from material design. How I get that is from this, and this has to run on the main thread context. So I was like, okay, well, it's going to notify on the main thread because I don't want to necessarily do this off the main thread. And I was like, oh, well, I should observe on because that's where I want to marshal it back to. But reading the details, I actually have to subscribe on, and it's because of the context of subscribe on, right? Subscribe on actually tells us that this is where you're going to get subscription and unsubscription notifications. So if this is going to notify on the main thread, that means that we have to subscribe on the main thread in order to get access to those notifications. So we're really talking about where we're boxing and unboxing the observable itself. And that's kind of like my last little bit, because I actually was getting a hard crash when this was happening, and man, was that ugly. But that's all I've got, folks. Just kind of a quick vignette into how you can do some of this stuff. I didn't even get into this page where things were breaking more, but yeah, all the fun stuff. This, let me get back to my slide deck real quick to show you that, that slide, blah, blah, blah. I know I'm over time, folks, so I apologize. So this is where you can get access to that code. It's going to be at Reactive Marbles social queue. So you can go look at Reactive Marbles, the same place that Glenn is doing that when property changed library. This app is available through there. You can fork it. You can ask questions. You can tell me it's horrible and that you found 10 better ways to do it. I'm all ears. So yeah, there's questions and I am ready.